All right. In today's video, we are going to look at transformations using arrow diagrams as we continue to explore what arrow diagrams can do for us. Um, the transformations, of course, we're familiar with are shifts, stretches, compressions, and reflections. And we will look at those as they happen in both the horizontal direction and in the vertical direction. So one of the things that arrow diagrams are big on are the inputs and outputs that are part of all functions. So we always want to associate what's happening in a horizontal direction with the input side of the arrow diagram and what's happening in the vertical direction with the output side. So let's get started with a shift in the horizontal direction. Our shifts we need to recognize as always being either adding or subtracting. And the unique part, we're going to see what's unique about arrow diagrams in doing this here. These obviously work on any kind of parent function. So I'm just generically at this point going to say it's some function, and I leave the parentheses empty there. What's at the beginning of the arrow is the input. What is at the end of the arrow is the output. Since this is a horizontal shift, then that means we want to make a change to the input side. The input side, then the only direction that we have available to us is away from the parent function. And we're always going to draw those arrows that go from right to left across the bottom, making sure we put the arrowhead on there because this is a one-way street here. And the unique part about the arrow diagrams with these is that we describe exactly what it is that we want to do. So this will be adding some constant onto there. And if I want to, for example, shift to the right by 4, then I'm going to make that a +4. If I want to shift to the left 6, I'm going to make that a -6. All right, so that's what our basic arrow looks like for shifts in the horizontal. On the vertical side, again, working on some generic function. Since this is a vertical, we'd be thinking in terms of shifting up or down. So we want to keep that in mind along the way as to what it is exactly that we're doing. Since this would be shifts up and down, that's the vertical direction. That is an output thing, so the arrow goes on the output side, and we add our constant over there, and up would be adding positive numbers, and down would be adding negative numbers. I may come back and put some examples in here in another video. We'll try to keep this one relatively short. For the stretches and compressions, this is multiplication and division that we see in here. And so, again, operating off of a generic parent function. This would be a stretch or compression in the horizontal direction. That is an input. So we need to make the change on the input side, and that would just be a matter of multiplying by some constant. If we want to stretch by 5, we would multiply by 5. If we wanted to compress by 1/3, we would multiply by 1/3. And on the vertical side, operating off of our generic function, this is a vertical stretch or compression. So vertical is the output axis, and so this goes on the output side and is multiplication by some constant over there. Our reflections we denote with a sign change. And generally, when I'm doing a reflection in the horizontal direction, what you'll usually hear is that's a reflection over the y-axis. So I just kind of, in my head, I imagine a y-axis, and those points would be reflecting back and forth. So that's a horizontal change that's happening there. That's how I recognize that it goes on this side. And that horizontal direction as inputs. So I do a sign change on the input side of the arrow diagram. And then finally, if I am doing a vertical or reflection across the x-axis, so the points are moving back and forth, up and down, rather, and that is in a vertical. The vertical axis is the output axis, so I attach my sign change to this side. And those are the only arrows that we need to remember for transformations. We'll do another video where we take a look at combining multiple transformations into one parent function. We'll watch how that goes.